2.6. In this activity, take about 2 ml of dilute NaOH solution. Take like this 2 ml of NaOH solution in one test tube and add 2 drops of phenolphthalein solution. First you take NaOH solution and add 2 drops of phenolphthalein. You know phenolphthalein, NaOH is base, already I told so many times, base phenolphthalein, BP. Next what is P? Pink. So what is the color of the solution? Pink. After adding 2 drops of phenolphthalein to base, you will get pink color, pink color. So to this pink color solution, add dilute HCl solution, drop by drop. After adding phenolphthalein, now start adding dilute HCl drop by drop, drop by drop. Is there any color change for the reaction mixture? After adding, what is the before adding the color here? Pink. Now after adding HCl, slowly adding, then you will observe one point, the color, pink color turns to colorless. Colorless. Why colorless? Why did the color of phenolphthalein change? Why it becomes colorless? After adding HCl, so this NaOH reacts with HCl and at one place neutralization is completed and it turns to acidic. So in acidic, phenolphthalein is colorless. Now add few drops of NaOH to the above mixture. After adding NaOH again, first is base. For base, phenolphthalein is added. So pink. After that HCl is added. It turns to acidic medium. In acidic medium it is colorless. After that again base is added, NaOH. Now what is the nature of the solution? Again it came to basic. Basic means again the pink color will come. Now add few drops of NaOH to the above mixture. Does the pink color of phenolphthalein reappear? Reappear? Yes, reappear. What do you think this has happened? Understand this activity. First you take 2 ml of NaOH solution, add 2 drops of phenolphthalein and what is the color? You observe color. After that again add HCl drop by drop. You observe the color. After that again add NaOH. Again the pink color came or not. Now you will see here what color change do you observe? The pink color reappears. After adding phenolphthalein, first color is pink. After that by adding HCl drop by drop, the pink color pink color disappears. Again after adding NaOH, the color, the question is that does the pink color of phenolphthalein reappear? Yes, the pink color reappears. This is because after the completion, addition of base makes the solution is basic. Now finally what is the nature of the solution is basic. Initially basic. In the middle by adding HCl it turns to acidic and finally it turns to basic. Thus it may be concluded that when phenolphthalein is added to NaOH solution, its color becomes pink, showing that it is basic in nature. When HCl is added dropwise, it becomes colorless, showing that the base is neutralized. The word is important, neutralized with an acid. On adding NaOH solution again, its pink color reappears. This is because after neutralization, addition of base make the solution basic. Here the one word came, neutralization. What is neutralization? Acid and base react to give neutral solution and this reaction is called neutralization reaction. Acid plus base gives salt and water. This reaction is called neutralization. It is about activity 2.6. Next activity 2.7. In this one, take a small amount of copper oxide. Copper oxide, it is already in first chapter explained. Copper oxide, what is the color of copper oxide? Black color. Copper oxide in a beaker and add dilute hydrochloric acid slowly while stirring. So take a small amount of copper oxide and in a beaker and add dilute hydrochloric acid slowly while stirring. Note the color of the solution. What has happened to the copper oxide? You see acid, here dilute hydrochloric acid, acid. What is the copper oxide? Copper is a metal. So copper oxide is metal oxide. So here acid reacts with metal oxide to form salt and water. Acid, what is acid here? Dilute hydrochloric acid. Acid reacts with metal oxide. Which metal oxide taken? Copper oxide to form salt and water. So acid plus metal oxide gives salt and water. So it is HCl. Copper oxide formula is CuO, and what is the product? CuCl2. What is the color of CuCl2? Blue color. It is important. Note the color of the solution. Before adding HCl, what is the color of CuO? Black color. After adding HCl, it turns to CuCl2. Copper chloride, copper salt. What is the color of copper chloride? Blue color. Black color copper oxide turns to blue color copper chloride. So from this activity, you have to remember that acids reacts with metal oxide to form salt and water. This reaction is similar to previous, that is 2.6. What is 2.6? Acid reacts with base, gives salt and water. Acid plus base gives salt and water. What is that reaction? Neutralization. In this reaction, acid plus metal oxide gives salt and water. It is here also product salt and water. What is the reactant? Acid. One more reactant is metal oxide. So you compare this activity and previous activity. From these two activities, you can conclude that metal oxide is basic in nature. Metal oxides are basic in nature. What is the nature of CuO? Metal oxide, basic. In activity 1.1, first chapter, first phase activity, magnesium oxide, metal oxide. What is the nature? MgO, basic. CaO, basic. CuO, basic. So these are examples of metal oxides. All metal oxides reacts with acid to form salt and water. It is about activity 2.7. Activity 2.8. So in this activity, take solutions of glucose, alcohol, hydrochloric acid and sulfuric acid. Take 4 solutions. You prepare solutions before starting activity in bakers and keep side. In one beaker, hydrochloric acid. In second beaker, sulfuric acid. In third beaker, glucose solution and alcohol solution. So 4 are there. 2 acids, sulfuric acid and hydrochloric acid. 2 another substances, glucose solution and alcohol. After that, this is the equipment. Fix 2 nails on a cork and place the cork like this. Fix 2 nails in a on a cork and place the cork in a beaker and connect these 2 nails through a 6-volt battery. Connect these nails through wires to 6 volts battery and pour dilute hydrochloric acid in this beaker. Dilute here, see, connect the nails to the about terminals of 6 volts battery through a bulb and switch as shown in figure. Now pour some dilute HCl in the beaker and switch on the current. Now you switch on the current. Then after that you observe, repeat same type, repeat this experiment with dilute sulfuric acid. First you start this experiment with dilute hydrochloric acid, second with dilute sulfuric acid. What do you observe? Repeat the experiment separately with glucose and alcohol solutions. What do you observe now? Does the bulb glow in all cases? That one only you have to observe in this activity. So it is the diagram. Take one rubber cork, fix 2 nails, connect these 2 nails through wires via switch and battery, via switch and bulb to 6 volt battery. Pour dilute HCl, switch on that one, you check bulb is glowing or not. Second one, you replace this solution and again you pour dilute sulfuric acid, again you observe bulb is working or not. Third, alcohol. Fourth, glucose solution. So with after doing this 4, what you will observe? Does the bulb glow in all cases? In 4 cases bulb glow is there or not? No. You will observe that the bulb glows in case of acids. In case of dilute hydrochloric acid first type and in second time dilute sulfuric acid. In case of acids only the bulb will glow. This means that the aqueous solution of acids conduct electricity. Aqueous solution of acids conduct electricity. Dilute HCl is a good conductor of electricity. Dilute H2SO4 is a good conductor of electricity. Acid solutions are good conductor of electricity. So that's why this bulb is working. However, the bulb does not glow. The bulb does not glow in case of glucose. In case of glucose, bulb is not working. In case of alcohol, bulb is not working. That means glucose solution and alcohol solutions are not conductors, do not act as conductors of electricity. Out of 4 solutions, acids too are good conductors of electricity. Why acids are good conductor of electricity? If acid HCl is taken, it gives H plus ion. H2SO4 is taken, it gives H plus ion. Acid is a substance which gives H plus ion in water according to first class definition. What is the definition of acid? A substance which gives H plus ion in water is called acid. You take HCl, it gives H plus ion in water. So inside ions there, these ions are useful to conduct electricity. While in case of alcohol, in case of glucose, there are no ions. Ions not there means conductivity not there. So to conduct electricity, which one is needed? Ions are needed. So acids are good conductors of electricity because of H plus ions. Similarly, base solutions are also acts as good conductor of electricity because of OH minus ions. Okay, it is about this activity. Next. Now activity 2.9. In this activity, take about 1 gram of solid sodium chloride in a clean and dry test tube. 1 gram of solid sodium chloride in clean and dry test tube. After that, add some concentrated sulfuric acid to the test tube. Like this, you take one test tube. In this test tube, sodium chloride is taken. For this, add concentrated sulfuric acid. After adding concentrated sulfuric acid to NaCl, the reaction between NaCl and H2SO4 will take place. One gas is released. Here you see, what do you observe? Is there a gas coming out of the delivery tube? Yes. One gas will come with a strong smell. Pungent smelling gas is evolved. What is that gas? That gas is HCl, hydrogen chloride. Test the gas evolved successively with dry and wet blue litmus paper. So like this, you keep nearby this gas, one dry litmus paper, after that one wet litmus paper. What is the colors changes? In which case does the litmus paper changing color? In which case does the litmus paper change color? That is the observation you have to do. On the basis of the above activity, what do you infer about the acidic character of dry HCl gas and HCl solution? So this is the activity. What you have to do? Take one test tube, fill little sodium chloride solid, and after that concentrated sulfuric acid. One gas is evolved. What is that gas? HCl gas. Nearby this gas you keep litmus paper, dry condition and moist condition. What do you observe? Note the change in the color of blue litmus. So there is no change in the color of the dry blue litmus paper. If you are keeping dry blue litmus, that means without water, you have to keep direct blue litmus paper near the mouth of this delivery tube. No change in color, no changing to blue litmus to red litmus, no change because it is dry. Dry HCl is not an acid. You have to remember, dry HCl gas is not an acid. But this shows that hydrogen chloride gas, dry HCl gas, does not behave as an acid in the absence of water because there is no water in dry litmus paper. If you keep moist litmus paper, it turns blue litmus to red. You will observe that the gas turns the moist blue litmus paper to red. This shows that HCl gas behaves as an acid in the presence of water. HCl gas in dry state is not an acid. It is a very important topic for exams. HCl gas is in dry state, it is not an acid. HCl in aqueous state, that means in the presence of moisture, it acts as acid. That means acid shows acidic behavior only in their water solutions. In the presence of moisture, of water only, it gives H plus ions. So in dry condition there is no H plus ion. Dry HCl is not an acid. HCl in presence of water is an acid. It is activity 2.9. Last activity in this class. Take 10 ml of water in beaker. Take 10 ml of water in beaker. Water. Add few drops of concentrated H2SO4 to it and swirl the beaker slowly. It is very important. Here you have to take more precautions. First you have to take water in beaker. Add few drops of concentrated H2SO4 it and swirl the beaker slowly. Touch the base of the beaker. After that adding acid to water, just to touch the base of the beaker. Is there a change in temperature? Is this exothermic or endothermic process? Repeat the above activity with sodium hydroxide pellet and record your observation. What you have to take? Take one beaker and add some water. After that you add some little concentrated H2SO4. After that you check the touch. By touching the beaker base, you will feel hot. You will feel hot. That means here heat is liberated. Heat is liberated means what is that reaction? Exothermic reaction. Exothermic reaction. That means dilution of acid is an exothermic process. Because you are taking concentrated sulfuric acid and you are making dilution. You are adding water means dilution. Because of dilution, heat is liberated. So it is exothermic process. Similarly, dilution of base is also exothermic process. So what do you observe? It will be observed that beaker becomes hot. That means addition of an acid into water is an exothermic process. Add acid into water slowly for dilution. Add acid into water slowly for dilution. Do not add water into acid. It is very, very important. Add acid. You remember. Add acid into water slowly for dilution and do not add water into acid. So like this, add acid to water, it is correct method. If you are adding water to acid, means it is wrong method. Sometimes explosion will take place because it will catch a vigorous reaction. Therefore, warning signs are marked on the bottles containing concentrated acids and bases. This process is incorrect. Addition of acid to water is correct. Addition of water to acid is incorrect. Okay, thank you. Based on these activities, based on all these lab activities, 10 activities, we can see some chemical properties. So reaction of metals with acids and bases. Already you seen zinc reacts with H2SO4, gives hydrogen gas. Zinc reacts with base also, NaOH, gives hydrogen gas. Zinc metal plus acid. You can use either HCl or H2SO4 in dilute. You will get some salt and hydrogen. So zinc metal with acid, hydrogen gas and salt. Metal with a base. Not all metals. Here all active metals will react. In this case, only amphoteric metal like zinc and aluminum. Zinc and aluminum like amphoteric metals only react with NaOH, gives Na2ZnO2. It is called sodium zincate. Sodium zincate and H2. Sodium zincate and H2. It is the first property, reaction of acid and bases with metals. We will see second, reaction of acids with base. Acid with base, already seen. Acid with base gives salt and water. What is the name? Neutralization reaction. What is neutralization reaction? The reaction between acid and base to form salt and water. Here two reactions given. One is reaction between HCl and NaOH. Second one, reaction between sulfuric acid and NaOH. Here salt is Na2SO4, sodium sulfate and water. It is about second property. Next, third, reaction of metal oxide with acids. Example were metal oxide, zinc oxide, aluminum oxide, CuO, copper oxide, MgO, magnesium oxide, CaO, calcium oxides. Already I explained metal oxides are basic. So metal oxide basic, so metal oxide reacts with acid, gives salt and water. Salt and water. You take example ZnO, zinc oxide, metal oxide. It is basic, reacts with H2SO4 acid, forms salt, ZnSO4 and H2O. So next property is reaction of non-metallic oxide with base. What is the non-metallic oxide here? CO2. Carbon is non-metal. Carbon dioxide is non-metal oxide. What is base here? CaOH twice. CaOH twice. So non-metal oxide reacts with base to form salt and water. It is also similar to neutralization. Salt and water are there. Base is there. Here CO2, non-metal oxide, is in the place of acid. That means you can say oxides of non-metals. Non-metal oxides are acidic in nature. Non-metal oxides, example CO2, oxides of nitrogen, oxides of phosphorus, oxides of sulfur, phosphorus, nitrogen, sulfur, chlorine, carbon, all these are non-metals. Their oxides are acidic in nature. They react with base to form salt and water. So, okay, thank you.